Alright, so this is 5.2 part 2. So again, we're continuing with what we did yesterday with our radicals and exponents. So an expression involving a radical with an index n, so remember index is the number out front, so we'll have the index in front of our radical, is in simplest form when these three conditions are met. So the first condition is no radicans have a perfect nth power as factors other than 1. So that means that we've taken everything out. So if we have something that we factor into, circle our groups of numbers, we've taken everything out that we can. So it's in simplest form when we've taken everything out that we can. No radicans contain fractions, and no radicals appear in the denominator of a fraction. So to meet the last two conditions, we have to rationalize the denominator. And to do this, we multiply the expression by an appropriate form of 1 that eliminates the radical from the denominator. So an example of that would be if we had, let's say, 2 over square root 3. We want to multiply the top and the bottom here by square root 3 in order to get rid of that square root 3 from the denominator. And we have to multiply the top by the same thing because multiplying by square root 3 over square root 3 is just multiplying by 1. So we're not changing the value of our fraction here. So 2 times square root 3 would be 2 square root 3. And what is square root 3 times square root 3? 3. Perfect. So we got rid of that fraction, that radical in the denominator, so we're good. So we can always multiply by the same thing to get rid of it, to get rid of the radical. All right, example 3, write each expression in simplest form. So let's look at A. Where do we start? Awesome, we need to find factors of 135. So what are some factors of 135? (27) and 5. What are factors of 27? 9 and 3. Factors of 9? 3 and 3. All right, so we broke down everything as much as we can. We're circling groups of how many? 3. So we're going to circle 3 of our 3's. So what comes out of the radical? 3. Do we have anything left on the inside? 5. So our simplest form would be 3 and then the cubed root of 5. So since we started out with an index of 3, our answer has to have the index of 3 also. It looks kind of weird because you got so many numbers in there right now, but just don't forget, whatever index you started with, that's what your answer has to have. All right, let's look at B. So we have a radical in the denominator. How do we get rid of it?
Multiply the top and the bottom by square root of 8.
The fifth root of 8? Yep. So we multiply the top and the bottom by the fifth root of 8. Whatever this is on the bottom, we multiply it by the same thing. Because the radicals end up, this one's a little bit more tricky because when you have square roots, you can just multiply it by the same thing. Because if we multiplied a square root of 8 by the square root of 8, under the square root, we have 2 8s. and then we would circle our 2 8s and take out the 8, right? But here we have the 5th root of 8. So if we multiplied by the 5th root of 8, we wouldn't have, they don't just cancel each other out. We would have too many numbers underneath our radical that it doesn't come out. So what we need to do is figure out what would make this like a perfect 5th root. What would give us 5 numbers here that we would circle all 5 and take out a whole number. So let's see what we can break down 8 into. So what are factors of 8? 2 and 4. And we can break down 4 into 2 and 2. So right now we have 2 2's under here. Now our goal is to get how many 2's, do you think? 5. So we need to multiply this by the 5th root of something with 2 more 2's, right? Because our goal is to get 5 2's, to circle all of our 2's and take out a 2. So we want to have something with 2 more 2's in here. So 4. So we're going to multiply the top and the bottom here by the 5th root of 4.
Miss Carver?
Yes.
Like I'm confused. Why don't we just do like quotient property?
Because then we would have a fraction under our square root. So what you're saying is, why can't we just do like the 5th root of 7 over 8? This one?
Yeah.
Because we can't have a fraction under our square root. That was, I think, rule number 3 or 2. That was one of our rules. Can't have a fraction under the square root.
Oh, okay.
So that's what we're trying to do, is get rid of that fraction. Good question. All right, so let's simplify our denominator now. We can combine the 8 and the 4, both under the square root. So this is 8 times 4. So the 8 we said breaks down into 3 2's. The 4 breaks down into 2 2's. We're circling groups of how many? 5. So we're going to circle all 5 of our 2's. And what comes out? So what comes out here? 2. So we're going to have a 2 on the denominator. Now we need to simplify our numerator. How can we simplify the 5th root of 7 times the 5th root of 4? Right, we can combine them under the same radical. So we have the 5th root of 7 times 4. What's 7 times 4? 28. Are we done yet? Maybe. Let's see if we can simplify the 5th root of 28. So if we have the 5th root of 28, what are factors of 28? 7 and 4. 7 can't break down anymore. 4 breaks down into 2 and 2. Do we have groups of 5 that we can circle? Nope. So the 5th root of 28 is as simplified as we can go. So this is our final answer.
Wait, but why'd you multiply it by 4, like in the beginning?
Because our goal is to get 5 numbers, 5 of the same number under our square root, so we can circle it and take out a whole number. So let's say if we multiplied this, I'm going to do it down here so we don't get confused. But let's say we multiplied the 5th root of 8 times the 5th root of 8. If we combine these together, we have the 5th root of 8 times 8, which is 64. If we break down 64, we get 8 and 8. 8 breaks down into 2 and 4, and 2 and 4. We have 2, 2, 2, 2, 2, 2. Our goal is to circle groups of 5, so we circle 5 of our 2's. But we're still left with 1 2 under the square root, so this would become 2, the 5th root of 2. But we want to get rid of that radical here. We don't want this in the denominator anymore. So that's why we had to figure out what number can we multiply here to give us 5 2s so we can perfectly take out 5 of the 2's. So that's why we had to do the 4. We need to look and see what our index is, and that's how many numbers we need here to be able to circle all of them and take it out as a whole number, because we want to get a whole number on the bottom. 5 minus square root 3, perfect. So what we do to the bottom, we have to do to the top. So we're going to multiply the bottom times 5 minus square root 3, and the top times 5 minus square root 3. Now, we're multiplying 1 times 5 minus square root 3, so what would we get on the top? 5 minus square root 3. And now let's multiply the bottom. How can we multiply 5 plus square root 3 times 5 minus square root 3? FOIL. So we're going to multiply our first terms. 5 times 5 is 25. 5 times negative square root 3 would be negative 5 square root 3. Square root 3 times 5 is 5 square root 3. And what is square root 3 times negative square root 3? Minus 3. Perfect. Those square roots cancel out. We end up with, so the long way of doing this would be square root 3 times negative square root 3. We end up with a negative square root 3 times 3. We can take out our group of 3's so it becomes a negative 3. So we get negative 3 when we multiply that square root 3 times negative 3. Now can we simplify anything here? Do we have any like terms?
Yeah.
25 and negative 3, so it's 25 minus 3? 22. What happens to that negative 5 square root 3 and the positive 5 square root 3? They cancel. So we're just left with 22 on the bottom. So this is our answer. So our answer looks a little bit more messy than the original, but our goal is to get that square root out of the denominator. So when you have a number being added to the square root, you have to multiply the denominator by the conjugate. You have to multiply the numerator and the denominator. But it's the conjugate of the denominator. All right, so let's do 29 together. Actually, that one was super similar to what we just did. So we'll do 32 together. So we have 11 over 9 minus square root 6. How can we get rid of that radical in the denominator? Awesome. Multiply by the conjugate, so we're multiplying this by 9 plus square root 6. And what we do on the bottom, we have to do to the top. So you want to work with the bottom first or the top? Let's do the top. Just get the easy part out of the way. So can't forget to distribute this 11 to both things on the inside. So what's 11 times 9? 99. And then 11 times square root 6 would just be 11 square root 6. So our top is done. Now we can work on the bottom. So how do we multiply 9 minus square root 6 times 9 plus square root 6? We have to FOIL. Yep. So 9 times 9 is 81. 9 times square root 6 would just be 9 square root 6. Negative square root 6 times 9 would be negative 9 square root 6. And then negative square root 6 times positive square root 6. What would that give us? Negative 6. Awesome. Now we want to combine our like terms. So what numbers are we combining here? 81 and negative 6. What's 81 minus 6? 75. And then what happens to the positive 9 squared root 6 and the negative 9 squared root 6? Cancel, cancel. So what are we left with on the bottom?
75.
Oh, 75. I don't know why I wrote 77. But yeah, 75. Yes, Casey? Yeah, you can have a negative on the bottom. So this is our final answer. Any questions on this one? All right, let's do one more of the other type. Let's look at 23. So I'm going to rewrite it over here. We have the cubed root of 5 over the cubed root of 4. So we want to get that cubed root of 4 out of the denominator. What does 4 break down into? 2 and 2. Our goal is to circle groups of how many? 3. So what are we missing here to make that a perfect whole number in our denominator? We're missing a 2. So we need to multiply this times the cubed root of 2. Whatever we do on the bottom, have to do on the top. Everybody with me so far? So in the denominator, we have the cubed root of 4 times the cubed root of 2, which would be the cubed root of 8. 8 breaks down into 2, 2, and 2. Circle all 3 of our 2's. So what do we get in the denominator? 2. Now let's work on our numerator. How can we multiply the cubed root of 5 times the cubed root of 2? The cubed root of 5 times 2. So what are we left with on top? The cubed root of 10. Perfect. We always want to make sure that we can't simplify the top anymore. But we know our factors of 10 are 5 and 2. 5 and 2. We don't have any groups of 3 to circle, so it's as simplified as we can go. So this is our final answer.